Hello dear students. So let's see what PDA does exactly. In the previous video, we saw block diagram of pushdown automata and we saw that PDA contains an infinite tape with input coded on that infinite tape, and then there is only a read head. We don't have write head, so we can only read one symbol at a time from this particular tape. And there is a state control. So PDA has finite set of states where Q0, Q1, Q2 can be the states. But most importantly, we saw that PDA has a push down store, which is a stack in which you can push or pop stack symbols. We also saw basic definition of PDA, how PDA is a 7 tuple and what is the meaning of Q, sigma, delta, tau, Z0, S and F. But I'm sure that this part of explanation won't be justified because a beginner doesn't understand the working of PDA from the given definition. So let's see what PDA does exactly and how it works. Just check that at any given instance, you can think of PDA is running, this machine is running, and you can think of an instance in that particular execution of PDA, that PDA will be in some state Qi, whatever. It might be in Q0, it might be in Q1, but PDA is surely in some state while it is basically executing. Let's assume that PDA is in state Qi, okay? And in this state, PDA reads some input, let's say A, it reads some symbol from the tape, and at that time, topmost symbol of the stack is X, some symbol, let's imagine. So top of the stack is X. Now PDA may perform the following. Now this is known as current configuration. Current configuration. That is, what is PDA right now reading? What is it reading from input tape? In which state it is right now? And currently, what is on the top of the stack? Which symbol is on the top of the stack? So three things define current configuration. Now, what PDA does in response to this current configuration is it might do the following. First, first it might do is it may change the state. From Qi, it may go to Qj. That's what DFA also did. When DFA, that is deterministic finite automata, was reading some input A in the state Qi, it may go to a state Qj. It may change or it may transit to some other state, or PDA may remain in the same state Qi. So on reading the input symbol A from the tape in the state Qi, we may result in a new state Qj, or we may stay in the same state Qi. The second thing PDA does is that it may push new symbols on the stack, or it may pop symbol from the stack, or it may leave the stack unchanged. So it will neither push nor pop any symbol on the stack. That's it. This is what PDA does. Now again, it's just so difficult to understand, I agree, but I promised, trust me, after going through these pictures or these diagrams, you will surely understand what we are talking about. So just imagine that block diagram of PDA, and currently you observe PDA is having this configuration. What is that? See this read head. Read head is currently at symbol A. So PDA is going to read symbol A from the input tape. And currently PDA is in state Q0. This was the state control, isn't it? Recall the block diagram. This was the state control. Currently, let's say PDA is in state Q0, and currently the stack stores a symbol Z0. That means we have three things. Input read is A, current state is Q0, and topmost symbol on the stack is Z0. And let us say that PDA enters this new configuration. This is the new configuration which is arising from this configuration. But then what does this mean? See that PDA has read the first symbol A, so read head automatically moves to the next symbol. So next time PDA is going to read the second symbol, but right now PDA has read the first symbol A. And notice PDA has not changed the state. PDA is still in Q0. But observe something more interesting. On the stack, there is a new symbol X, which is on the top of Z0. You can just see this stack in the current configuration and this stack in the new configuration. There is a new symbol pushed. So can you relate it like this? Can you relate? What really has happened is PDA was in state Q0. This state was Q0, isn't it? And after reading symbol A in the state Q0, PDA remained in the state Q0. Okay. And secondly, PDA pushed. There was a push operation done, and on top of Z0, there was a new symbol X which was pushed. Just a word of caution. Don't start tangling, don't start thinking that why are we doing this? We are trying to understand the configuration and the delta function. Just follow my explanation, and I promise you will really understand this in and out. How we can explain this configuration? We can say that what is happening exactly over here is, just check, if we say that PDA was in state Q0, correct, comma, in that state PDA read symbol A, correct, comma, and at that point of time top of the stack was Z0. I mean symbol on the top of the stack was Z0. This are the three things that we were discussing in the working, isn't it? It is in some state Qi, it is reading some symbol from the tape, and top of the stack is something, isn't it? So currently Q0 is the state, A is the symbol, and Z0 is the top of the stack. So three things we are having in the current configuration. And what does it result in? What does it result in really? So we write this as delta function. Delta here is a function of three things: current state, current input, and current top of the stack. What does it result in is the machine is still in the state Q0. See this? See this state has not changed here. State is still Q0, and Z0 was the top of the stack, isn't it? But on top of it, there is a symbol X pushed. Look how we have written X before Z0, indicating that if you draw this stack literally X followed by Z0, this will be the stack drawn, isn't it? So we get a new configuration where the machine is still in Q0 state, but the top of the stack is no more Z0, top of the stack is X. Also, the input tape now has next symbol to be read as A, the second A, because the read head has automatically moved to the next symbol. Okay, let's see. Can you now understand this configuration? Just see this. This is the current configuration of PDA. That means PDA is reading this symbol A, correct, from the input tape, and PDA is currently in the state Q0. But look at this, top of the stack is now X. So what are the three things we are having? Current state is Q0, current input is A, and top of the stack is X. We define delta as the function of these three things. But then what is the result? What is the result and what PDA does? Remember, PDA will move on to the next symbol. So next time it is going to read B, but currently it has read this A. And look at the state, it is still in Q0. It has not changed the state. But there is something interesting happening in the stack. Notice this was the topmost symbol, isn't it? We had X and Z0 on the stack, but on top of it, there is X pushed. This is a push operation where x has been pushed on top of x. So how do you write this? This results in, you write, machine is still in Q0 state and top of the stack was x, and now there is a new x, new symbol x, which is pushed on top of that x. I hope you are understanding. Well, when we write our resultant configuration, we write only what was at the top of the stack and what has been pushed on top of that. Look, we don't write the complete string of the stack, that z0 was there, then on top of that x is there, then on top of that x is there. We don't write it because in the input configuration we said that top of the stack is x. Now in the resultant configuration we say that that x is still there, but on top of it new x, new symbol has been pushed. Okay, what do you understand from this configuration? Keep repeating, keep repeating this discussion. What do you understand from this configuration? Now currently b is getting read from the input tape and q0 is the current state and the top of the stack is x. So we again have three things: current state q0, symbol getting read is b, and top of the stack is x. Let's talk about delta function. Okay, delta is a function of three things and it will take up an action. Now observe what has happened. PDA has moved to the next symbol b. So next time PDA will read this b, but currently PDA has read the first b in the input. But notice, machine is no more in Q0 state. It has changed the state to Q1. And observe that we had x, then x and z0 on the stack. But this x has been taken out. This x has been taken out, and now we have only one symbol x and z0. This is clearly a pop operation. So how do you explain this? In state Q0, machine reads b, top of the stack is x. This results in machine now lands up in Q1 state, and look at this symbol epsilon. What we are meaning here is top of the stack was x, but that x has been replaced with epsilon. So you can think of that this x has been replaced with empty, that is epsilon. So it means that we have removed x, the top symbol from the stack has been removed. Of course, whatever was there on the stack is still preserved, but the top symbol has been removed. Okay, keep repeating this. What if I give you this configuration, double A, double B, and now the read head is at this point and the machine is in Q1 state, and notice the stack now is containing Z0 and X. Okay, this is the current configuration, and suppose PDA lands up in this new configuration after this. Notice after this last symbol we know that there is a string of nothing, null string. So now PDA has moved its read head to epsilon and machine is still in Q1 state, but notice the stack now has only Z0. Observe the input configuration. Which state we are? Q1. What are we reading? B, correct? And what was the top of the stack? X. Let's define delta, transition function. What has machine done? It is still in Q1 state. And you notice that this x, notice this x has been now removed. You can see that x has been replaced with epsilon. Epsilon means nothing. So this is clearly a pop operation. I hope you are understanding. Okay. What do you say about this configuration? Double A, double B, epsilon, and machine is now reading epsilon and it is in Q1 state. And currently the stack is having only Z0. And imagine that the new configuration that we have is A, double B, epsilon, epsilon, and now the machine is in Q2 state, but look at the stack still has Z0. Look at the input configuration and resultant configuration. One thing is sure, after reading epsilon, the machine has moved to new epsilon, the next epsilon, but notice it was in Q1, but now machine is in Q2 state. And also notice top of the stack was Z0 and top of the stack is still Z0. That means there is no change made to the stack. How can you define this? Machine was in Q1 state, okay, and machine reads epsilon from the input. Notice it has read epsilon from the input and the top of the stack was Z0. What will be the delta function? The delta function over here would be machine is in Q2 state now and the top of the stack which was Z0 has been kept as Z0. There is no change made to the stack. Stack remains unchanged. You notice this is what we were saying in the working of the PDA. Check this second point. PDA may push new symbol or pop symbol from the stack or leave the stack unchanged. And this is exactly an example. The last diagram that we had drawn, there was no change made to the stack. Now just imagine I give you these configurations. Just check these delta functions. Q0 A Z0 maps to Q0 X Z0. And for the same PDA, I give Q0 A X maps to Q0 comma X followed by X. Again, Q0 B X maps to Q0 epsilon. And finally, this is Q1. This is Q1 and Q1 B X maps to Q1 epsilon. Okay, this was not needed, I think. Wait a minute. Yeah, this was not needed. I wrote it again. Okay, and one more we are having here. One more transition. Delta Q1 epsilon and Z0 maps to Q2 Z0. Now, given this transition functions or delta, you will be able to draw picture of a PDA in the form of states. Rather, whatever we are going to now draw is exactly same as whatever has been written in the form of delta. Let's see how to draw a PDA. Q0 is the initial state, and we say in Q0 state, when machine reads A, and at that point of time, when the top of the stack is Z0, then we keep Z0 as it is, but push X on top of it, but the machine stays in the state Q0. Which delta or transition step does this represent? This exactly represents the first delta we have written in Q0, machine reads A, top is Z0. So in Q0, machine is reading A, top is Z0. This slash says the action taken. So after slash, we write the action taken is that Z0 is still there, but X has been pushed. So XZ0 has been written and machine stays in Q0. Notice machine has not changed the state. So we will get a loop. Okay. How will you write this delta? Q0AX. What that means is in the state Q0, machine is reading A again, but the top of the stack is X. And what is the result you watch here? The result is that X stays, but on top of it, one new symbol X has been pushed. And most importantly, machine stays in Q0. So we will again have a loop here. I hope you are understanding. Then comes this delta. What do you have in state Q0? Machine is reading B. Observe this delta function and top is X. But the machine changes to Q1 state. Observe PDA changes to Q1 state. So here we have a transition where we say that in Q0, if the machine reads B, in Q0, if the machine reads B and top is X, then machine will replace this X with epsilon. Observe this epsilon over here. So we'll write slash epsilon. But the most important thing is machine is now in Q1 state. Okay, finally, how will you write this delta? Machine is in Q1 state and it is reading epsilon. Machine is in Q1 state and it is reading epsilon. Top is Z0. but machine lands up in Q2 state and keeps the stack unchanged. So this can be shown as machine is reading epsilon, but the top is Z0. But that Z0 is kept as Z0. There is no change to the stack done, and machine is in Q2 state. And let us say that Q2 is the final state, so we will draw Q2 with double circle. Please try to understand, if we label this Q0 as the initial state and Q2 as the final state, this PDA diagram is absolutely same as whatever steps have been written here, because we have drawn this PDA with the help of delta function. This PDA actually recognizes or derives a language which is of the form a raised to n, b raised to n, such that n is greater than or equal to 1. We will see how exactly this happens and how we came to this conclusion. But I feel that more such exercises on configuration and first of all drawing the PDA, how to draw the PDA, should be understood, which we will see in the next videos. And then we will come to the construction of PDA or logic building. Thank you very much.